Hi, my name is Tim Mackey, and I'll be presenting today the poster session 4093.1 titled A Technical Framework to Leverage Blockchain Technology to Combat Healthcare Fraud and Abuse. I'm going to go ahead and share my screen, so give me 1 second. So today's discussion will be about a research project that we've been working on at the San Diego Supercomputer Center and the Block Lab at UC San Diego. I have the following disclosures to make. I am currently the CEO and co-founder of the big data, machine learning, and blockchain startup company S3 Research, in addition to my faculty appointment at UCSD. S3 Research was created and is currently funded through funding from the National Institutes of Health and the SBIR program, and has not received any funding from any private companies. So the goals of this particular project that I'm discussing today is to propose and conceptualize a method using blockchain technology to combat healthcare fraud and abuse with distributed ledger technology. And so if you know anything about blockchain technologies, it's oftentimes associated with cryptocurrencies. It is actually simply the framework for which cryptocurrencies operate under. So we wouldn't have cryptocurrencies unless we had forms of distributed ledger technology. At the core of distributed ledger technology is the ability to share multiple ledgers across multiple participants. And we're going to use this framework essentially to add the patient or beneficiary of a particular Medicare claim as a validating node to the network. So instead of just submitting a claim to a payer like CMS, essentially the patient would have a role in the process of validating that that claim was actually received and was valid. So again, one of the largest components of this project is to make the claims process for healthcare fraud and abuse prevention much more patient-centric. Another thing that's one of the primary components of this project is to have a more proactive fraud and abuse protection system. Currently, most of the fraud and abuse is adjudicated through whistleblowers who then are machine learning with data sets retrospectively. This way, we would have an ability for the patient to act as a validator and prevent claims potentially from being filed and reimbursed if they were involved in a fraudulent transaction. So if you know anything about healthcare fraud and abuse, it's one of the largest sectors of criminal activity. And this activity in healthcare fraud and abuse has been increasing over the last few years. In 2018 alone, there was a huge takedown related to healthcare fraud and abuse, including over $2 billion in losses and over 600 defendants charged. There are a number of ways that healthcare fraud and abuse can occur, including through False Claims Act, or basically submitting a false claim, upcoding, billing issues, and also anti-kickbacks, also violations of the Stark Law. So there's many different ways that essentially companies can defraud the US government, and also providers can defraud the government. And of course, given the size of the healthcare industry, this is a ripe target for criminals to engage in fraud. So what our project proposes, and I can only describe so much in this short time frame, is that we want to move the process for adjudicating claims and make it more decentralized. So currently on the left side, you see that patients often receive a healthcare service or don't receive a healthcare service. They directly liaise with the provider, and the provider then bills a payer. In this case, we're going to be talking about the Center for Medicaid and Medicare Services, CMS, throughout this presentation, as one of the largest payers, the largest payer in the United States. What we want to do is to create a blockchain framework where these nodes of participants, including providers and patients, are actually connected to each other, and that CMS would have full visibility to claims as they are adjudicated. And so would the patient and the provider. An example of the practical application of this using blockchain technology is when a provider who is authorized to provide services under CMS and bill CMS sends a bill for a service. And along with that often comes a prescription for a particular medical device, drug, etc. This is then shipped to a medical supplier, which we're using medical equipment as our example here. But every time some new reimbursement data is written, everyone in the network can see it, including CMS. So in this case, a medical device supplier is actually going to bill for a wheelchair, and they submit essentially a block of data talking about receiving a reimbursement for a wheelchair, but the patient is actually only receiving a walker. So in this case, the patient has the ability to validate that the claim was not the correct claim, because they see both what the provider is submitting to CMS, and they also are the person who actually is receiving services and can validate whether their claim is correct or not. So in this way, we have the ability to give the patient visibility to what's being claimed by the provider, and also validating that that is the service that they received. The way we accomplish this is through a prototype system that we developed on Ethereum, which is one of the larger blockchain platforms that are used now primarily for smart contracts. And it involves 3 different application layers, basically an application stack. The front end being, of course, the UI UX component, where people actually input the data that interfaces with the underlying blockchain architecture, which is built on Ethereum, and then a back-end database that stores a lot of that data that is called for example, validate that an insurer is actually a Medicare provider, to validate that a service claim matches with a particular patient record. And so there's a lot of interoperability issues. There's a lot of discussion about how you ensure that data is generated correctly and in a common data format. We address that a lot in a paper that I'll talk about, but I won't go over the details here. But there's a data schema we came up with, and it links to the specific adjudication process for CMS claims. So, one of the things I can say is that the detail related to this particular study has been published in the Journal of Medical Internet Research. It was published during the time that this abstract had already been accepted. And so that's the best place to look for additional information. It's called Combating Healthcare Fraud and Abuse, a Technology Framework and Prototype Leveraging Blockchain Technology. And it gives you all the details on how we developed this prototype system. The prototype is available on our GitHub repository for the San Diego Supercomputer Center, and you can download it and interact with it in that manner. But one of the more important things about this paper that also is included in the discussion is our linkage of the framework's utility to existing CMS fraud and abuse and patient data initiatives, including one thing called the My Health eData and the Medicare's Blue Button 2.0, which essentially is an API that allows patients to push their healthcare data to other providers. So this is a way that CMS is essentially working very hard to enable patients to share their data, collect their data, and view their data so that that data can be used in a more appropriate way. So in this way, we hope that the patient also has a role in validating claims to save money for the government and to protect certain areas of our healthcare system from fraud and abuse. So this just gives you a quick visualization of some of the components. We broke up the prototype into, of course, the payer, the provider, and the recipient. So each of them has a process where they can validate a claim, and you can also add a cryptocurrency layer or a token layer to incentivize, for example, patients to report their problems when it comes to fraud and abuse, or to ensure that you're collecting that data. And we also see value in this data being aggregated so that you can detect anomalies in claims data processing. Maybe there's some verification data that's really strange. And of course, there are limitations to the system, such as when a patient themselves are a part of a fraud and abuse scheme. So some of those issues have to be kind of figured out. But again, it's another layer of protection for healthcare claims. So I'll close with that and just mention that this is a project that was funded through the San Diego Supercomputer Center, through the Block Lab. Block Lab is a place where we do a lot of interdisciplinary research related to all types of industries. I am the principal lead for healthcare related blockchain use cases, and we have several corporate partners who are also are helping us with interpreting how the system works and its commercial utility in the future. So thanks again, and I look forward to questions and conversations via the virtual chat and questions on APHA's platform. Thank you very much.